Welcome back, students. So, coming back to our lesson. So, we were talking about wonder number 6. So, let us go to the wonder number 6, and that is. Oh, okay, wait. Shruti is not the wonder number 6, for your kind information. Now, why I wrote the name Shruti is this is an example, just an example. So, now let me go back, let me take you all to the previous chapter, permutations and combinations, or the way I like to call it, that was arrangements. So in the previous chapter, arrangements, this type of examples were shown with the names Pandana and Raja. With these two names I showed you some things. The same thing I want to show you with the name Shruti. How many letters, or how many words can you make with these 6 letters? How many different words can you make? So it will be 6 factorial divided by 2 factorial. Why 2 factorial? Why am I dividing by 2 factorial? Because 2 i's are there. I's are identical. There are 2 i's, which there are 2 identical terms. Therefore, I need to divide by 2 factorial, because otherwise there will be an overcounting. Because even if I interchange the i's, the name, it will look the same. There will be no difference. You will get the same name. Therefore, I need to divide by 2 factorial. Now, suppose I take another name, a little more hard, difficult one. That is Niharika. It's a little more difficult because there are 2 sets of identical terms. That is, there are 2 i's and 2 a's. So what will be the answer? It will be 8 factorial divided by 2 factorial into 2 factorial. Why 8 factorial? Because 8 letters, and 2 factorial is because 2i, and the other 2 factorial is because there are 2 a's. Okay, now let me give you another weird name. I know this is a weird name, Tata. I have to take this name to show you something. That is, suppose you have a 5-letter word. There are 5 letters in this word, and this word consists of only 2 alphabets. There are 5 letters in the word, but the word itself has only 2 alphabets, A and T. That means something has to repeat, right? Only if there is repetition you can have this word, because there are 5 letters but only 6 alphabets. So the answer will be 5 factorial divided by 2 factorial into 3 factorial. Why 2 and 3? Because there are 2 a's, and 3 factorial because there are 3 t's. Now, if you look at these two, in these two, if you look, we can see that, or we can infer that, we can observe that the 2 and 2 here are not dependent on each other. They are independent. Why? Because this value 2 doesn't affect this value 2. Okay, let me show it in this example. Look at this 2 and 3. This 2 and 3 is dependent on each other, because this value 2 is what determines what this whether it will be what this value will be. See, because there are, as I told you before, there are 5 letters in the word but only 2 alphabets. So how many times one alphabet repeats, it depends on how many times the other alphabet repeats. Let me write it this way. There are 2 ways of writing this. One way is 5 factorial divided by 2 factorial into 5 minus 2 factorial. This is one way of writing it. And another way of writing it is 5 factorial divided by 3 factorial into 5 minus 3 factorial. You see that there are 2 ways of writing it, and you see how it is dependent. You see, if I am taking you see 5 minus 2 and 5 minus 3, you see that these numbers are dependent on the other number. And if you look carefully, you will see that this is in the form of n factorial divided by n minus r factorial into r factorial. And what is that? NCR. So our combination, this is basically our combination formula. So I can write this as 5c2 and the below one as 5c3. Okay, so guys, I want you to pay very close attention to what is happening here. Give me your undivided attention, because this will be a little tricky if you're not, I mean, this will feel a little tricky later if you're not giving a full attention. This is not difficult, let me tell you, this is not difficult, but these are very new things. I mean, binomial theorem is a new thing which you have not studied till now, so that is why I want you to pay and give your undivided attention. Okay, so let's continue. So again we are coming back to our binomials. So I have a plus b to the degrees 1 2 3 4. Now let me start with a plus b to the power 1. You will get a plus b. A plus b to the power 2, it is a plus b into a plus b. Now I know that you know the identity a square plus 2ab is b square, all that I know that, but I want you to multiply this directly. Just open the term as you would multiply two polynomials, and because I want to show you something. So when I open it and multiply, it will be aa plus ab plus ba plus bb. Now if I write them together, it will be, as you studied, a square plus 2ab plus b square. Now look at a plus b whole cube. I can it is basically a plus b whole square into a plus b. So when I open them and multiply, it will be aaa plus aab plus aba plus abb plus baa plus bab plus bba plus bbb. So you see that there are a lot of terms, and if I bring the like terms together, I can write them like this: a cube plus 3a square b plus 3ab square plus b cube. Now a plus b whole to the power 4. This I can write it as, okay, I'm not going to do all the expansion. I'm going to write it directly. That is a to the power 4 plus 4a square b plus 6a square b square plus 4ab cube plus b to the power 4. Now if you look at these two, AB plus BA, just look at this carefully. You see that this AB and BA, I've written them both together as AB. It looks like I didn't even care about the order. AB, A into B and B into A. Both of them I wrote it as A into B. Why? Because I don't care about the order. A into B is same as B into A, right? The order doesn't matter. What matters is what letters are there, and how many times a letter appears. Okay, take the next one for example. Look at these three terms. What is common in these three terms? There are two A's and there is one B. In all these three terms, there are two A's and there is one B. So I wrote them as A square B. It doesn't matter. See, all three are not written in the same order, okay? One is ab, one is aba, next one is ba. You get it? So it is not written in the same order, but the order doesn't matter. What matters is what are the letters, and how many letters are there. So it is a square b. Same thing with the other three terms also: abb plus bab plus bba. So that I write as ab square, because there are two b's and one a. So what do you see from all this? We do not care about the order in these things. Now when you do not care about the order in arrangements, what is it? Combinations. Yes, you're right, we are coming back to the same old chapter. There's a reason why I taught you that chapter first. So now I mean, yeah, of course, I taught you that chapter first for another reason, that is true. But anyways, it all came out for good. So now I am giving you three spaces, three slots, and I'm giving you three letters A, and B. Now, what I want you to do is, I want you to arrange. I have given you two A's and one B. Now you can arrange in different ways. And how can you tell me how many ways can you arrange them? Basically, it is 3 factorial divided by 2 factorial into 1 factorial. Now I know that 1 factorial is not necessary. I just wrote it for a reason, to make you understand something which I'll tell you later. Now the 3 letters are there. That means there are 3 factorial ways of writing it. Right. So I wrote the 3 factorial. Now because 2 letters are identical, I divided by 2 factorial. And because B comes only one time, I wrote it 1 factorial. Even if I write it or do not write it also, it doesn't matter. You know that. Because 1 factorial is 1 itself. But just for uniformity's sake, I am writing it like this. So 3 factorial divided by 2 factorial because 2 A's are there, and 1 factorial because only one B is there. Suppose I'm taking that away, I'm giving you a new set of letters A, B and B. 2 B's and 1 A. What will be the answer? 3 factorial divided by 1 factorial into 2 factorial. 1 factorial because only 1 A is there. 2 factorial because there are 2 B's are there. Now, what are these things? This is basically 3 factorial divided by 2 factorial into 3 minus 2 factorial. See, remember the names example, Shruti, Niharika, Tata. Remember those 3 names. This is I'm continuing with the same concept. So 3 factorial divided by 2 factorial into 3 minus 2 the whole factorial. Now, what about the other number? It will be 3 factorial divided by 1 factorial into 3 minus 1 the whole factorial. Now this is the n factorial divided by r factorial into n minus r factorial. So basically it is NCR, that is 3C2 and 3C1. Now guys, this is exactly the same numbers here. 3C2 is 3 and 3C1 is also 3. Both of them are actually equal. So that is how these numbers come, 3 and 3. Now let me take you to another example. Look at this. I'm putting 4 slots now, and I'm giving you 4 letters A, and B. How many ways can you arrange them uniquely? Everything should be unique. You can arrange in these many ways. That is 4 factorial because 4 letters are there, divided by 3 factorial because 3 A's are there. A's are repeating, so 3 A's are there and there is 1 B. So 4 factorial divided by 3 factorial into 1 factorial. Now suppose I'm taking that away and I'm giving a new set of letters, 2 A's and 2 B's. Now how many ways? 4 factorial divided by 2 factorial into 2 factorial. Okay, suppose I'm taking that away and giving you a new set of letters, A, B, B, B. 3 B's and 1 A. Now how many? 4 factorial divided by 1 factorial because only 1 A and 3 factorial because there are 3 B's. Now guys, what are these things? This is basically 4C1 and this is basically 4C2 and this is basically 4C3. Now if you look carefully, this is, if you connect things, these are the numbers. 4C1 is, this is 4C1, this is 4C2, this is 4C3. Look at it. There are 3 A's and 1 B, 4C1. There are 2 A's, 2 B, A square B square, 4C2. There are 1 A and 3 B's, 4C3. You see how these numbers connect each other? Now what about this thing? If I give you 4 B's, B, 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 how many ways are there to get to arrange them. It is 4 factorial divided by 4 factorial because 4 b's are there, and 0 factorial because no a's are there. There are, a number of a is 0, so 0 factorial. Number of b is 4, so 4 factorial. And basically, logically, we know there's only one way of arranging everything. But doing it for calculation's sake, it will be 4 factorial divided by 0 factorial into 4 factorial, which is basically 4c4. Now suppose I take that away and I give you another example, another set, a 4 a's. How many ways are there? 4 factorial divided by 4 factorial into 0 factorial. Why? Because 4 factorial because there are 4 a's, and 0 factorial now because there are 0 b's. You get it? So I can write this as 4c0. Actually these two are same, 4c0 and 4c4 are same. You can write this. I know, you might get confused why I'm using 4c4 here. I'm using 4c0. This is just for the pattern sake, because this is going in increasing order 1 2 3. I just use that. These two are the same. 4c0 and 4c4 are the same thing. Only thing is, there are 4 a's and there are 4 b's. It doesn't matter, you can change it. But since you look at the middle terms, it is 1 2 3, the value is increasing. So to follow the pattern, I'm just using that. Okay, now these are the same numbers here. This is 4c4, and which is the answer is 1, and this is 4c0, the coefficient that is 1. 4 a's, a to the power 4 is 4 a's, and b to the power 4 is 4 b's. So you understand, so do you understand something? Do you understand what is happening here? There is there's a relation between algebra and arrangements. Guys, the maths that you studied, in the previous classes, the algebra, the algebraic identities, these things are connected with permutations and combinations. Do you understand how it's all related together? Now let us come to a general format. When we come to a general format of things, this is how it comes. A to the power a plus b whole to the power n. See, you can always use Pascal's triangle and write the things, it is always possible. But instead of using Pascal's, because when numbers are too big, it is, you have to write the whole Pascal's triangle, so it will be difficult. So this general format will help you. So, and this I have written as an example. You can look at this example. This is a plus b whole to the power 4 example. If you look, you will see the same thing. Now if I generalize it, it will be nc0. First number will also, remember before it was 4c0, right? Before it was 4c0. So and it increases 4c1, it increases 4c2, like that. So likewise, when I put n, when the power is n, the first coefficient will be nc0, then a to the power n. Here also look, it is a to the power 4. So likewise, a to the power n, and there is no b's. So first term there is no b's. Then there is nc1, a to the power n minus. The power of a's, keeps on decreasing. Each term, the power of a keeps on decreasing. You see, look at this example. It is a to the power 4, a to the power 3, a to the power 2, a to the power 1. Then it's actually nothing is there. Nothing is there means it is a to the power 0, because it is 1. So you see that it's decreasing. So likewise, the a powers keeps on increasing. First term is a to the power n, then a to the power n minus 1, then a to the power n minus 2, then keeps on decreasing, and last it becomes a to the power 1, and then here it becomes 0, a to the power 0, a to the power 0, the answer is 1. What about the second term? What about b? B doesn't come in the first term because it is b to the power 0, so it doesn't actually come. Now second, b starts appearing from the second term. So from here onwards, b to the power 1, b to the power 2, it keeps on increasing to b to the power n minus 1, and last is b to the power n. So we see that b to the power of b keeps decreasing from right to left, while the power of a's start decreasing from left to right. It depends. If you write this as b plus a to the power n, it becomes the opposite way. So you get it. So it depends on how you write also. But anyways, I hope you're able to understand this. If you can come whenever you have a doubt, you can just compare it with any identity that you know. Use the same identity, a plus b whole square, a square plus 2ab plus b square. You see that a power is decreasing, b power is increasing. So this is something that we see when we generalize it. So guys, what have we learned? We have learned that you can find the expansion of anything to the binomial to the power of anything, any integer, of course, any positive integer, a to the power of any positive, even negative integers also now you can find, because yeah, actually a to the power of any integer you can find. And actually not even integer, but you have not studied the NCR of rational numbers, so it won't be possible for you to do right now. But if you know that also, then this can be expanded to it can be expanded to rational numbers also. It can be expanded to the whole of real numbers. Anyways, for now, let me stop it here. I don't want to confuse you a lot. There are too many things told in the video. Please rewatch them. Go back, rewind, just watch it again if you have a doubt. But clear the doubts in this. If you have any doubts in this thing, clear it before the next topic, because next topic, of course, will be based on what I have taught today. Okay, so yeah, thank you guys for listening. So that will be it for today.